Hello everyone, welcome back to another video where today I'll be going over adding and subtracting polynomials. So this is pretty simple to do, very similar to what I showed you in the like terms lesson. You needed to know that for this lesson, but the part I did at the end is very similar to what I did here. So when you're adding polynomials, what you can do is you can actually just get rid of these brackets. So you can just rewrite this as 2x plus 3 plus 5x minus 2. Okay, so sorry for the messy handwriting, but you guys know where I'm coming from. So to add this polynomial, what you have to do is you have to find the like terms. So what are like terms again? Well, like terms have the same variables and the same exponents. So like terms here are, I'll do this in different color just to show you, are the 2x and the 5x, right? And then the other like terms, this is a plus sign, this is a multiplication sign, my bad. Let me make that more neat. Maybe I'll just stay on this side of the board. 2x plus 3, all right? And I'm not going to circle these. 3 and the minus 2 are like terms. So I'm going to rewrite this equation out again. So this is equal to 2x plus 5x plus 3 minus 2. I haven't changed anything. I've just rewritten this in a different order. And now that we know what our like terms are, we can add them. So what's 2x plus 5x? Just 7x. And 3 minus 2 is 1. So positive 1 plus 1. So that's the answer. And you cannot simplify this any further because we do not know what x is. So that is our final answer. So I'll go over another example. And yeah. Alright, so we have another question here. Looks a little more difficult than the previous question, but same process. So what you can do here is, since you're adding the polynomial, you can just get rid of the brackets. So 5x plus 2y plus 5 plus 10x plus 7 minus y. So let's identify the like terms here. Well, let's start with 5x. What other, whatever you want to call it, what other term has x to the power of 1? To the power of y? Nope. 5? Nope. 10x? X and x to the power of 1 to the power of 1? Yes. So these are like terms. Alright? Now let's do 2y. Alright. Does 5 have a y in it? It does not. Does 7 have a y in it? It does not. This is a y, and we can assume that if there is no number in front of a variable, we can just assume there's a 1 there. So y to the power of 1, we can just assume that, and because there's no exponent. Same thing here. So these are also like terms. So okay, and now that just leaves us with 5 and 7, and those are obviously like terms, so I don't need to circle that. So going back to the question, let me rewrite this out again. You should put an equal sign here. I didn't because I'm lazy and I forgot, to be honest, but let's just rewrite this out in a more clear order. So we have 5x plus 10x plus 2y minus y. I'll write minus 1y to make it clear, but typically you wouldn't do that on a test. You just write minus y plus 5 plus 7. Okay, and now we can just do our addition and subtraction with the like terms. So 5x plus 10x is just 15x. 2y minus 1y y. 2 minus 1 is just 1. So it's 1y. So let me just do this on the side here. 2y minus 1y equals, this is 1y, so you would write it like this, I guess, but typically in math, when there's a 1 in front of something, you don't write the 1 in front of it, because 2 minus 1 is 1, and the y is the like term here. So typically, you just write this as y. You don't write 1y, so 2y minus 1y. Because the general assumption is you don't write the 1, I'm just going to put y here. But it's the same thing as 1y. And then we have 5 plus 7. That's just 12. So that is our answer. Yeah, pretty easy. So now I'm going to go over some subtraction. And subtracting polynomials is a little more complicated, but it's not too bad. So let's go to the next question. All right, so now we have a subtraction question. So before, with the addition, we would just remove the brackets, but it's not so simple now. So when you're subtracting polynomials, there are many ways to do it, and your teacher might show you a different method. I'm going to show you the way I do it, and hopefully you like it. Otherwise, you'll just find another method. So when you're subtracting, what you have to do is you have to distribute this negative to all of these terms in the second bracket. And this actually leads to our next lesson, distributive property. So basically this minus sign has to be distributed here, and it has to be distributed to the 8. It doesn't have to be distributed to the first bracket because it's just applying to anything to the right of it. And when I mean by distribute, I mean by multiplying. So think of the minus. This is also -1 really, but you don't write it again. You just write the minus sign. So I'm going to rewrite this as, we'll keep the brackets. Actually, no, we don't have to keep the brackets. So after we distribute this, so this is probably better if I do it to the side here. So let me just write this out here separately. 2x plus 8 is equal to what? So we just distribute this -1, but you don't write the 1, to 2x plus 8. So -1 times positive 2x is -2x. Okay? You have to know some grade 8 stuff here. I'm not going to go over that. So if you don't know how to add and subtract integers and stuff like that, go watch a video on it. But I'm not going to be covering it. And then we have -1 times 8, positive 8. That's just -8. So therefore, this 2x plus 8 becomes -2x minus 8. And once you've distributed the negative to the second bracket, you can do the same thing. You can do the same thing you did with addition. So you can just get rid of the brackets. So 5x plus 10. And now you use these numbers, not these numbers. You use these ones. So you write -2x minus 8. And now you just gather your like terms again and you simplify. So I'll just circle them. 5x, 2x, and 10 and 8 are like. So 5x plus 2x, pretty simple. 5 plus 2 is 7x. Keep the variable the same. 10 minus 8 is 2, positive 2. So that's your answer. All right, so pretty straightforward. You will need to know all of this for the more complex algebra that's going to come up. But yeah, pretty simple.